solution multiplied by 100. Now, do you guys know what a solute is? Maybe we should just step back and review that for just a moment. You have a system here, okay, and let's say you've got salt put into water, okay. Well, one of these is a solute and the other one is the solvent. Now, in a particular case like this, H2O would be the solvent. Salt would be what is called your solute. And the whole entire shebang together would be called your solution. Okay? So, if you knew what the mass of your salt was, you would put that in the top line. And then you would have to weigh the whole entire solution, put that in the bottom line, times 100. Okay? So you would not want to take the solute plus the solvent and add those together. You don't want to do that. You want to take the solute and then the whole thing together. Now, why would you want to do that? Is it because conservation of mass is not conserved? No, that's not it at all. The idea is if you start weighing these things separately, there can be things left around on the side of the container. So see, if you mix it all in one container and weigh it, then all of your ions are inside that glass, and there are none left on another piece of glassware. Does that make sense? Now, which one's the solute and which one's the solvent, right? So let's say I had 13 grams of pyridate dichlorobenzene, and let's say I had 3 grams of naphthalene. Which one's the solvent and which one's the solute? Right, the solvent is the PDB, the pyridate dichlorobenzene. And the reason she knew that, and that's the reason, see, everybody's heard of salt water. I put this up here because you probably haven't even heard of that. It's the one that's in the most amount is defined as the solvent. So what if you had a salt-water mixture and there was 100 grams of salt and 1 gram of water? Which one would be the solvent? The salt would be the solvent. And that's highly unusual, that's silly, that's stupid, but that's the way it is. Okay, the one that's in the most amount is the solvent. The one that's in the least amount is the solute. Okay? So, I have to be sure that we got the difference between solution and solute and solvent. Now, if you do not see percent WW, if you just see the word percent, that is the same thing as a percent by mass. They just assume that you know that because it's the most common. Now there's another one. It's called a percent WV. And that stands for a weight volume. And what that means is that's going to be the mass of the solute divided by the volume of the what? Solution times 100. So what's the difference? Here you're dealing with mass, here you're dealing with volume. If you deal with aqueous solutions, will these two things be the same or different? Well, I guess technically they would be different. But remember, water has a density of what? 1 gram per milliliter? Nominally. So volume of water and the mass of water are what? Pretty much the same. All right. Now, Bella said they're different, and they are. I mean, salt water does have a different density than regular water. It's still around 1, but it is certainly different. You know, if you're an analytical chemist, it's different. Okay, how are we doing with that? Wonderful. Well, what would happen if? You got 0 degrees centigrade here, right? You have 100 degrees centigrade here. Okay? And I want to ask you about the boiling point. What does water, pure water, boil at? 100 degrees centigrade. Now what if you have 3,000 gallons of water, what temperature would it boil at? 100 degrees. What if you've got 1 milliliter of water? What temperature will it boil at? 100 degrees. What about the density of water? What if you got 3,000 gallons of water? What's the density of water? 1. What's the density of a milliliter of water? 1. So density does not matter how much material you've got, right? What about boiling point? Does that matter how much material you got? No. Those are what are called non-colligative properties. Those are properties that it doesn't matter how much you got. They're the same throughout, right? Okay. Now, this right here is pure water. This right here is pure water. Okay. Now what happens if you add salt to pure water? What will that do to your freezing point? Well, it turns out that your freezing point will drop. If you add more salt to your water, what happens to your freezing point? It drops some more. If you add another teaspoon of salt to your water, what happens to the freezing point? It drops some more. All right? So this right here is what is called freezing point depression. That means that your freezing point will drop when you mix something in the water. Period. Freezing point depression. Now let me ask you this. Is freezing point depression then a colligative property? In other words, does it matter how much you sprinkle in? Huh? Yeah. Sure it does. That's why I went through this whole big thing. Whenever you're adding extra teaspoons of salt and this number is changing, then it does matter. That is a colligative property. Because if it didn't matter, then Bella could add 1 teaspoon of salt and she could sneak in behind her and add 14 other teaspoons of salt, and guess what? This number would do what? Remain the same. All right? But if Bella boils pure water, it's boiling at 100 degrees centigrade, she goes out for a cigarette, she dumps another half a cup in there, what's the temperature still going to be? 100 degrees, right? I mean, once it heats up a bit, right? In the time frame of a cigarette smoke, I suppose. All right, so the mathematical term for this right here is called delta T sub F. That means freezing point depression. Now, freezing point depression happens in couples with something called a boiling point elevation. In other words, pure water boils at 100 degrees. If you add salt to it, it'll boil at 103. If you add more salt to it, it'll boil at 105. If you add more salt to it, it'll boil at 108. The more salt you add, the higher the temperature of the boiling water. Okay? And you can certainly try this at home if you want to. Well, be sure you've got a thermometer that will handle it and not one you put underneath your tongue. All right? But you can go to the lab, and next semester we do this. We go to the lab. You get boiling water there, you read it off, and the water's boiling at like 99.5 degrees centigrade or whatever the atmospheric conditions is out there.